Advanced port technology integrates specialized equipment and container cranes, optimizing maritime logistics through precision automation, efficiency, reliability, and intelligent cargo handling operations worldwide. After a 2-month voyage from Shanghai, 5 ZPMC ultra-large container ship handling cranes arrive at ECT Delta Terminal on January 14, 2014. The arrival marks a major milestone for the terminal's infrastructure development. Designed to handle the world's largest container vessels exceeding 18,000 TEU, these cranes significantly enhance operational capacity and efficiency. Compared with early container cranes of the 1980s, the hoist level has increased dramatically, from approximately 30 meters to nearly 50 meters today. This extended reach allows safe and precise handling of containers on ultra-large vessels, supporting the growing scale of global maritime trade. A spreader twin lift is a specialized heavy-duty lifting device designed for modern ports and container terminals to handle 2 standard 20-foot shipping containers simultaneously. By enabling dual container handling in a single crane cycle, this technology significantly increases operational efficiency, boosts terminal throughput, and reduces vessel loading and unloading times compared to traditional single-lift operations. The twin-lift spreader is mounted on large cargo-handling cranes, such as ship-to-shore cranes, rail-mounted gantry cranes, and rubber-tired gantry (RTG) cranes. Its core advantage lies in its dual-box design, where each container is lifted independently through dedicated hydraulic or electric systems, ensuring high stability and precise control during hoisting, trolley movement, and landing. Most modern twin-lift spreaders feature telescopic capability, allowing them to adjust their length to accommodate various container sizes, including 20-foot, 40-foot, and 45-foot units. A key functional element is the adjustable center gap, which enables safe lifting of 2 20-foot containers even when spacing deviates from standard configurations, a common situation in busy or irregular terminal yards. Constructed from high-strength European steel, twin-lift spreaders are engineered to withstand harsh port environments. They incorporate advanced safety systems such as overload protection, secure twist-lock mechanisms, and compliance with international standards like EN 13001. Available in hydraulic or electric versions, as well as fixed or adjustable configurations, spreader twin lifts offer flexibility to meet diverse operational demands. The container loading operation carried out by a high-capacity container crane at Laem Chabang Port, Thailand. From the crane control room, operators carefully monitor every stage of the loading process, ensuring accuracy, safety, and efficiency. Crane 8 is shown in operation at LCMT Port A0/1, handling containers destined for the vessel Vega Kappa. Using advanced control systems and precise movements, the crane lifts containers from the terminal and positions them accurately onto the ship's deck. The operation demonstrates the crane's ability to handle heavy loads while maintaining stability and speed. Located in Sriracha, Chonburi, Laem Chabang Port is one of Thailand's most important logistics hubs, where modern container cranes play a vital role in supporting smooth maritime trade and efficient port operations. The following narration explains the correct procedure for using the wing lift container support system in a safe and efficient manner. Begin by removing the corner units from the transport rack and placing them on stable ground near the container. Next, release the twist lock devices and remove the upper locking pins to prepare the corner units for attachment. Carefully align the locking bolts with the ISO corner castings of the container, ensuring precise positioning, and securely fasten each unit in place. Once installed, adjust the angle of the corner units so they sit firmly against the container walls, providing proper load distribution and stability. After alignment is confirmed, fit the tow beam to the corner units and lock it securely. The tow bar is then connected to the tow beam, forming the main towing structure. Proceed by fitting the steering arms to both the corner units and the tow bar. This step is essential to allow controlled steering and smooth maneuverability during transport. When all mechanical connections are completed, hoist the container to the preferred operating height using appropriate lifting equipment. With the container raised, connect the wing lift system to the towing vehicle, ensuring all couplings are fully engaged and locked. Remove the handlebars once towing control is transferred to the vehicle. At this stage, the system is fully assembled, properly secured, and ready to move the container safely and efficiently. The presentation introduces the latest VDL automated guided vehicle delivered to ECT in October 2015. This AGV represents a new generation of electrically driven, diesel hybrid vehicles developed by a consortium of VDL companies specifically for modern container terminals. Designed for intensive operations at the ECT Delta terminal in the port of Rotterdam, the AGV's primary role is to transport sea containers efficiently from ship-to-shore cranes to the designated storage areas. The vehicle features an advanced hybrid drive system equipped with ultracapacitors developed by Siemens. This technology enables energy recovery during braking, resulting in significant fuel savings and a substantial reduction in emissions during operational testing. The VDL AGV is capable of handling containers up to 45 feet in length and can carry loads of up to 70 tons, making it suitable for heavy-duty port logistics. Its modular design focuses on lowering operating costs, improving reliability, and simplifying maintenance, while also minimizing environmental impact. VDL began delivering these AGVs in October 2013 at an average rate of 1 unit per week. The final vehicles of the 85-unit order were completed around July to August 2015, making the October 2015 delivery the last of this series. After extensive testing by ECT, each AGV has since transported over 100,000 containers, demonstrating proven performance and durability in real terminal operations. At Jawaharlal Nehru Port Trust, cargo unloading operations are carried out efficiently using high-capacity container cranes. As the container vessel is securely berthed at the terminal, ship-to-shore container cranes are positioned along the quay to begin the unloading process. Each crane operator carefully lowers the spreader onto a container, locking it firmly at the corner castings before lifting it from the ship's hold or deck. Once lifted, the container is moved horizontally toward the land side of the terminal. The crane then lowers the load with precision onto a waiting truck positioned beneath the crane. Terminal personnel and automated systems coordinate closely to ensure accurate alignment and safe placement of each container onto the truck chassis. After the container is secured, the truck immediately departs the key area, transporting the cargo to the container yard for storage or directly to the terminal gate for onward delivery. This well-coordinated crane-to-truck operation ensures smooth cargo flow, minimizes vessel turnaround time, and maintains high productivity at one of India's busiest container ports. A tower crane is a tall, stationary, heavy-duty machine widely used in construction to lift and move massive materials such as steel sections, concrete panels, and formwork. At the heart of this complex lifting system is the tower crane cabin, also known as the operator cabin, or cab. Positioned high above the ground, the cabin serves as the protected control center, where all crane operations are managed with precision. The cabin houses the crane's control panels, joysticks, monitoring displays, and communication systems, allowing the operator to control slewing, trolley travel, hoisting, and load positioning. Designed for long working hours at extreme heights, modern crane cabins prioritize safety, efficiency, and operator comfort. They are enclosed with reinforced structures, large panoramic windows, and climate control systems to ensure clear visibility and stable working conditions in all weather. Ergonomic seating, adjustable controls, and vibration-damping features help reduce operator fatigue and enhance accuracy during repetitive lifting cycles. Safety systems, including alarms, load indicators, and emergency controls, are fully integrated into the cabin to prevent overloads and operational risks. Overall, the tower crane cabin plays a critical role in ensuring safe, efficient, and precise material handling on large-scale construction projects such as high-rise buildings and major infrastructure works. PSA Breakbulk Corporate is a specialized joint venture dedicated to the efficient handling of steel, general cargo, and complex project cargo at the port of Antwerp-Bruges, one of Europe's most important logistics gateways. Operating in a highly demanding industrial environment, PSA Breakbulk combines local operational expertise with the global strength, standards, and innovation of the Singapore-based PSA Group, one of the world's largest and most respected port operators. The company is strategically positioned to support heavy industry, construction, energy, and infrastructure projects that require precise cargo handling beyond standard containerized operations. From steel coils, plates, and profiles to oversized machinery and heavy lift components, PSA Breakbulk is equipped to manage cargo that demands specialized lifting techniques, skilled operators, and strict safety controls. By leveraging advanced terminal equipment, optimized workflows, and experienced personnel, PSA Breakbulk ensures safe, reliable, and time-efficient cargo movements from ship to quay and onward to road, rail, or inland waterways. Its operations are closely integrated with the wider logistics network of the Port of Antwerp-Bruges, enabling seamless connections to European and global markets. As part of the PSA Group, PSA Breakbulk adheres to high international standards in safety, sustainability, and operational excellence. This combination of global expertise and local focus makes PSA Breakbulk a trusted partner for customers seeking dependable breakbulk and project cargo solutions in a competitive maritime environment. In late November 2011, a massive floating dry dock measuring 165 meters in length and 35 meters in width broke loose from its moorings at the southern quay of the Öresund Dry Docks facility in Landskrona, Sweden. On the 27th of November, extreme weather conditions and an unusually high seawater level caused the 6,000-ton structure to drift eastward toward the Bay of Lindakra. Remarkably, the dock passed over extremely shallow waters and eventually stranded approximately 3 kilometers from its original position. It finally came to rest in a highly sensitive Natura 2000 protected area, creating a serious technical and environmental challenge. Due to the minimal water depth of only 0.5 meters and the strict environmental restrictions of the protected zone, conventional salvage methods were not an option. Maritime therefore developed an unconventional solution. Inspired by Archimedes' principle of buoyancy and innovative engineering thinking, the team decided not to move the dock to the water, but instead to bring the water to the dock, literally thinking inside the basin. Preparations began at the end of January 2012 under harsh winter conditions. Using approximately 200 crane mats and 175 steel beams, Maritime constructed an artificial basin of around 28,000 square meters surrounding the stranded dock. At the same time, 3 excavators worked continuously to dig a channel 1.8 kilometers long and 2 meters deep, connecting the basin to open water. Inside the basin, an additional gully was excavated to a depth of 2 meters, creating a pocket where the dock could regain buoyancy. Despite freezing temperatures, all preparations were successfully completed by the end of February. The first movement occurred when the basin was flooded with approximately 60 million liters of water. As the water level rose, the dry dock slowly refloated. Once afloat, it was carefully repositioned using a combination of winches, anchors, and cranes, aligning it precisely with the newly excavated channel and positioned above the deeper gully. After repositioning, the basin was gradually emptied, lowering the water level back to sea level. At this stage, only favorable weather and tidal conditions were required. When conditions aligned, the dock was moved slowly and steadily through the narrow channel toward open water. On the 14th of March 2012, the floating dock exited the temporary channel and was towed back to Orsson dry docks by 2 tugboats, assisted by a third. The operation attracted many spectators who witnessed this extraordinary maritime salvage. Executed with exceptional precision and environmental care, the project was completed on schedule, and restoration of the natural area began immediately afterward. On the Demerara River in Georgetown, Guyana, a complex and highly demanding salvage operation is underway to remove a sunken vessel that has become a serious hazard to navigation. The wreck lies buried deep beneath the riverbed, trapped in an extremely dense layer of clay. Over time, the vessel has sunk nearly 6 meters into the muddy bottom, where the clay holds it firmly like liquid cement. Because of these conditions, a conventional lifting approach is impossible, and the salvage team must rely on a unique and highly skilled method to free the wreck. To penetrate the thick mud, the crane operator begins by dropping a massive 17-ton steel chisel onto the sunken vessel. Repeated impacts break the structure into smaller, more manageable sections. Once the wreck is fragmented, a heavy gravel grab is used to dig down into the riverbed and haul the debris up piece by piece. However, the mud is not the only obstacle. The Demerara River has a very narrow estuary, creating extremely fast currents that can reach up to 4 knots, especially during spring tides near the full moon. The 200-ton crane barge used in the operation cannot maneuver under its own power in such conditions. Instead, it relies on a support tug, commanded by Captain Eddie Corsi, to help position and stabilize the barge. The barge is held in place using 4 massive anchors. By carefully tightening or slacking each anchor line, the crew can move the barge in all directions while keeping it steady against the powerful current. This precise anchoring system is critical for maintaining control during lifting and cutting operations. As the wreck is gradually dismantled, a growing mountain of scrap metal accumulates on the barge deck. The broken steel is later transported to a yard in Paramaribo, Suriname, before being sold to scrap dealers and recycled at iron mills. On deck, the crew works closely together to organize the enormous piles of steel. Crane trainee Kevin Turto de Croma operates a small excavator to stack the shredded ship, while a team of cutters uses high-powered torches to reduce oversized pieces into manageable scrap. Visibility underwater is almost zero due to heavy silt, making cameras useless. As a result, the crane operator must work entirely by touch. With 42 years of experience, crane operator Henry van der Meulen relies on the feel of the crane to locate the outline of the vessel and judge where to cut. This level of blind operation demands exceptional skill, as strong currents can easily push the chisel off course, risking it becoming trapped in the mud. One of the most challenging lifts involves a midsection weighing around 50 tons. Caked with heavy clay, its effective weight nearly doubles, pushing the crane to its limits. To solve this, Henry carefully dips the massive section into the fast-flowing river, using the current to wash away the clay before lifting it onto the barge. After a week of continuous work, complicated further by heavy rain and slippery conditions on deck, the crew retrieves the final pieces, including large anchors and chains left behind from earlier failed salvage attempts. A final seabed survey confirms the wreck has been completely removed. Despite working blindly in harsh conditions, the team successfully clears the 55-meter vessel from the riverbed, restoring safety to this vital shipping route on the Demerara River. The RAM Revolver is an advanced revolving spreader system designed to handle containerized bulk cargo in a highly efficient, clean, and environmentally friendly manner. Developed to meet the growing demand for flexible and sustainable port logistics, this system enables dry bulk materials to be transported, stored, and discharged using standard containers without relying on costly, fixed bulk handling infrastructure. At its core, the RAM Revolver is used to lift specially designed open-top shipping containers equipped with sealed lids. These containers are transported using existing port equipment such as mobile harbor cranes, ship-to-shore cranes, or container handling vehicles. Once positioned above the vessel's cargo hold, or a receiving hopper, the system performs a semi-automated discharge cycle that ensures fast, controlled, and dust-free unloading. The operating sequence begins with the revolver securely engaging the container through standard ISO corner fittings. After lifting, the container is moved to the unloading position using conventional port cranes, eliminating the need for dedicated bulk cranes or conveyor systems. Upon arrival, the sealed lid is released in a controlled, semi-automatic process, preparing the container for discharge. The revolver then rotates the container through a full 360-degree motion, allowing gravity to empty the bulk material directly into the ship's hold or hopper below. Once discharge is complete, the container is rotated back to its upright position, resealed, and returned for reuse. This method is known as containerized bulk handling and represents a significant shift in how bulk commodities are managed. Materials such as grain, mineral sands, wood chips, coal, and metal scrap are treated as containerized cargo rather than traditional loose bulk. As a result, terminals can avoid the installation of expensive bulk infrastructure such as silos, conveyors, and dust extraction systems. Additionally, the risk of material loss during transfer is greatly reduced, improving cargo integrity and operational cleanliness. One of the most important advantages of the RAM Revolver system lies in its environmental performance. By transporting and storing bulk materials in sealed containers, the system effectively prevents dust emissions and cargo contamination. This is particularly critical in modern ports, where strict environmental regulations require operators to minimize airborne particles and spillage. The sealed handling process also protects surrounding communities, port workers, and sensitive ecosystems from pollution, making the RAM Revolver a future-oriented solution for sustainable port operations. In terms of efficiency, the system has proven to deliver outstanding performance. RUT became the first terminal in Europe to adopt the RAM Revolver technology, significantly increasing its biomass export capacity. With unloading rates reaching up to 800 tons per hour, the system outperforms many conventional bulk handling methods while maintaining superior environmental control. This high throughput allows vessels to be loaded faster, reducing berth time and improving overall terminal productivity. Another key strength of the RAM Revolver is its flexibility. The spreader is designed to be compatible with a wide range of existing port cranes, including mobile harbor cranes and gantry cranes. This compatibility allows multi-purpose terminals to integrate the system without major structural modifications or large capital investments. As a result, ports can quickly adapt to changing cargo types and market demands. handling both containerized and bulk cargo with the same equipment. In conclusion, the RAM Revolver represents an innovative and practical solution for modern bulk cargo handling. By combining containerization, rotational discharge technology, and compatibility with existing port infrastructure, it delivers high efficiency, operational flexibility, and strong environmental performance. As ports worldwide seek cleaner, smarter, and more adaptable logistics systems, the RAM Revolver stands out as a proven technology that bridges the gap between container and bulk handling in a sustainable and cost-effective way.